Good evening, one and all present here. Now I request Mr. Vasisthar from final year mechanical engineering to propose the welcome address.
Greetings from our sister, a student chairperson of IE, Department of Mechanical Engineering from Institute of Technology. Very good evening to one and all present gathered here. On this auspicious occasion, I would like to welcome you all for today's online workshop. Stars shine at night, but some stars shine at day bright light. It's our pleasure to welcome one such star, Mr. Vigneshwaran, the Honorable Chief Guest and speaker for today's workshop. Also, I welcome the Honorable Faculty in charge of IE, Mr. Jebin, Department of Mechanical Engineering, Ramco Institute of Technology, who giving us the opportunity to conduct this type of events. Also, I welcome the student secretaries, Mr. Tojes and Sridharan. I welcome you guys. Last but not least, I sincerely welcome all my student friends. You are strong and smart. Once again, I welcome you all for this workshop. Thank you. I request Tojas Nanda to introduce our chief guest for this workshop. Thank you.
So thank you, Vasisthar bro. So I am here to introduce our chief guest, Mr. K. Vigneshwaran. So he completed his BE in 2015 at Institute of Roads and Transport Technology in E-Road in the stream of mechanical engineering, and he completed his ME in solar energy in 2017 at College of Engineering Gindi. Now he is working as the assistant professor in Department of Mechanical Engineering in Ramco Institute of Technology, Rajapalayam. So he has published two papers in the fields of solar desalination techniques, and he also published papers in the 4 conference, in which 3 in national level in Tamil Nadu and 1 at the international level. And he acted as the resource person for the various programs conducted in RIT. So before handling the section to Mr. K. Vigneshwaran sir, I would like to give some instructions to the participants. So once you get into the page, kindly mute your audio and video. It is mandatory, and we will enhance the webinar quality. So wait for the resource person to present his screen so that everyone can hear and see the speaker alone. Once the presenter presents his screen, it will be automatically displayed on your screen. If you have pinned any other screen, the presentation will not be visible. So you are asked to pin the presentation presenting the screen in your mobile in the side box. So in case of you have any questions or queries, you can type the same in the chat box after the presentation. At the end of the speaker will be answering your question. If you accidentally leave the meeting, you can rejoin the meeting by clicking the same link. So a feedback link will be posted in the chat box at the end of the section. So thank you, participant. We expect your fully cooperation during the entire webinar. Thank you. Now the section is yours, sir.
Thank you, Tojesh Nanda and Vasisthar, for your welcome address. Is my screen is visible to everyone?
Sir, your screen is visible, sir.
Okay, thank you. So, good evening, one and all present here. So myself, Vigneshwaran, working as an assistant professor in Department of Mechanical Engineering, Ramco Institute of Technology, Rajabali. So on this today's webinar, we are going to see an introduction to a software which is called TracePro. Okay. So in today's webinar, these are the following agendas. So first we will see about introduction about TracePro. So what the purpose of this software and what are the application areas the software is helping and helping the researchers. Okay, so and after that we will see what are the tools which are present in software that is TracePro. So and how we have to draw a geometry in the software. So after we will see what are the grid sources we have to apply, and we have to apply the properties of materials. Okay, so like that we will see, and again we will see about the how we have to take the results and how we have to analyze the results from the software. Okay, so these are the things in TracePro. And the third is we are going to see a demo of a solar parabolic trough collector. So how we have to trace and how we have to obtain the flux results from the TracePro software for a parabolic trough collector. So and after that we will come for the discussion. Okay, so introduction part. So this TracePro software is a commercial optical engineering software, so which is mainly used for analyzing optical and illumination systems. Okay, we know that optics, which is nothing but it is a Greek word which meaning appearances. Okay, and we know that illumination, so that is intensity of light that is falling on certain object and or certain place. Okay, so this is the software which is used to analyze the light, that is optical systems. Okay, so which is developed by a Lambda Research Corporation of Littleton, USA. So in the year 1994. Okay, so from this from 1994, several versions of this software has been released by the Lambda Research Corporation. Okay, so now presently the software they are using is TracePro, that is 7.1. Okay, so the cost of the software which is not free, so it is a cost of around $2,500 to around $3,000. Okay, so you can purchase this software by requesting a mail to Lambda Research Corporation, so which is directly available in the website. So you can also download the demo version for your convenient use. Okay, so why where this TracePro software has been used means, so it has been used in areas where the light plays a prominent role. So for example, aerospace, defense, lighting, biomedical, illumination markets, and mainly for designing and analyzing the solar collectors, this TracePro software has been used. Okay, so next we will see what are the things we are going to see in the software. So first we are going to see what are the tools which are available in the software. So going for seeing this, I'm directly going into this demo version which is I'm having TracePro. Okay, so I hope you are seeing this interface of the TracePro software. Okay, so the first main elements, these are insert, define, race trace, analysis. Okay, so these are the four main elements which plays a prominent role, and you have to play with these four elements in the software. Okay, so first you have to choose the model. Okay, so in insert there will be several options available. So here you can choose the lens element. Here you can choose the Fresnel lens, and you can choose the reflector. You can choose the tube, and for inserting, for deflecting, or for the passage of flow of light, we can use baffle vanes. Okay, for inserting primitive solids, you can use this. For inserting different parts like cylinder, sphere. Okay, so you can use these components. Okay, so first one is a lens element. So if you select this lens elements, a dialog box will be appear like this. A box will be appeared like this. Okay, so here you can choose the name lens 1, lens 2, like that. It is depending upon your wish. Okay, so here all the units will be in mm. Okay, so here you can choose the radius as well as you can choose the curvature of the lens. Okay, and also you can insert the value of thickness of the lens. Okay, so here you can able to choose the material. Okay, depending upon the Ohara, that is a company name, Ohara, which is a glass company name. Okay, so for there will be several options available. So ice, glass, coating, like that. Okay, so it is depending upon your requirement, you can choose this material. Okay, and after that you can select the radius as it is your wish as 20, and you can insert a lens. Means you can see yeah, the lens will be inserted. Okay, so there will be in the user interface, the global coordinates will be in X, Y, and Z axis. Okay, so here at the bottom right end, X, Y, and Z. Okay, it represents at what position the lens or the object has been placed. Okay, so uh, here there is an option which is called orbit view. Okay, so in this orbit view, if you select, and you can able to rotate, and you can able to see the lens. Okay, it is selected, so it is like that. So here there is if you expand this lens, there will be two surfaces, that is surface 0. So the surface 0 is the lower part. Okay, and if you choose the surface 1, so it is the upper part. Okay, so like that you can able to distinguish the surfaces. Okay, so this is for lens. Okay, so like that you can able to insert different materials. You can insert the tube. Okay, so for example, a tube which is of cylindrical in shape, its thickness is 1 and its length is 100 mm. Okay, so its base radius is around 10. So like that, if you insert means yeah, you can able to see this uh, tube in the interface. Okay, so you can zoom out with the help this options available at the left top left. Okay, so you can zoom in and you can zoom out. Okay, so this is how you have to insert different things. Okay, here you can insert a reflector also. I hope you have heard about different solar collectors, parabolic trough collector, compound parabolic trough collector. Okay, so here there will be several reflectors which are available. Okay, so you just click the trough collector, you can name it, and you can select the options depending upon your need. So whether it is a parabolic trough collector, hyperbolic, or elliptical. So like that you have to select, and you have to give the length, thickness, depth, focal length of the collector. Okay, so and this is the X, Y, Z coordinate system. Okay, at what position your collector should be on the interface. Okay, so like that you can give. So and it is also the rotation in terms of degree in X, Y, and Z axis. Okay, so these are the different things available in this software. So there is you can easily made a component of tube. Okay, so you can easily made a component of reflector, lens element. Okay, so just by giving the dimensions and depending upon your uh, need. Okay, so this is the first thing, that is modeling. Okay, so while modeling itself if you select this or if you expand the tube selection, there will be three surfaces available. So that is surface 0, surface 1, surface 2, and surface 3. Okay, so if you select surface 1, so this is the a black color, so this is the surface 1. So if you select surface 2, surface 1, so this the outer port, that is part of the tube, this is the second surface. Okay, so third surface, so on fourth surface. So these are the inner tube and outer tube. Okay, so if you expand these surfaces, there is a option will be available as a surface property, which is selected as none. Okay, so you have to choose the surface property. Okay, so whether the tube is of a perfect absorber or perfect reflector, or whether the tube is made up of glass. Okay, so like that you can able to apply the properties by selecting by right clicking, and you can see the properties. Select the properties means there will be several options available here. Okay, so here you can choose the material. Okay, so if you choose the material, so if it is quartz, it is depending upon your wish, you can able to apply the material properties. Okay, so at what material the particular product or particular part has been made. Okay, so from this list you can able to uh, select the material. Okay, so and after that you have to click the apply. Okay, so since it is was a demo session, you cannot able to apply. So if you have yes licensed software available in your institute or in your home, means you can able to apply this properties. Okay, so and here also you can able to choose the surface. Okay, so whether it is a black coated surface or whether it is a white coated surface. Okay, so whether it is a perfect observer or whether perfect mirror. Okay, like that several options are available. So if you select, you can able to select and you can apply, means the particular properties has been applied to that particular surface. Okay, so this is the second thing you have to know about this. Okay, so and the third one is ray tracing after, sorry, and the second one is source. Okay, so here you have to select the source. Okay, so since this software uh, is a optical and illumination software, so the source is the light. Okay, so you have to choose the source. So by selecting the second column, that is source, here you can see a grid source like that will be available. So you can able to expand, this means a grid source like that will be expand, and from that you can right click and you can able to see a dialog box that is called define, and from the define you can able to select the grid source. Okay, so here you can able to select the grid setup. Okay, so in this grid setup you can able to choose this shape of the grid boundary, whether it is a annular or whether it can be a rectangular. Okay, so it is depending upon your wish, you can able to select. Okay, so also you can able to choose the radius of the grid. Okay, so here you can able to select the grid pattern, whether it's circular pattern or rectangular. Okay, like that. Okay, and after that you can able to choose the units, whether it is a radiometric or whether it is a photometric. Okay, so photometric, it is nothing but it is a measurement of light in terms of how humans can able to see its visibles. Uh, that is if you stand nearby a tube light, means its wavelength will be different, and if you stand apart from the tube light, means its wavelength can be different. Okay, so you can able to choose a radiometric or a photometric options will be available. So if it is photometric, the unit will be in lumens. So if it is radiometric, the unit will be in watts. Okay, so and next is flux per ray. Okay, so there is will be options available: irradiance, total flux or flux per ray. Okay, so mostly you go with irradiance, that is in the unit of watt per meter square. Okay, so irradiance, it is nothing but the total amount of light which is receiving from the source. Okay, so for sunlight, the maximum irradiance is 1057 watt per meter square. Okay, so that is the maximum amount of irradiance which is received by the earth from the which is received by the earth from the sun is 1057 watt per meter square. Okay, so with the help of instruments, we can able to measure the irradiance of sun, and we can able to measure the irradiance of light. Okay, so depending upon the value we are getting, you can able to give the values, that is from ranging from 1 to lakhs. Okay, so here also you can be able to choose the grid positions in the global coordinates x, y, and z axis. Okay, so it is depending upon your wish, and after that you can insert. So like if you have inserted means you can see a red symbol, the grid source has been placed in this user interface. So if you select a rectangular, so you can able to modify. So you have to, so if it is have a rectangular, you have to give the length and breadth. Okay, so this is the grid source. Okay, so from this grid source only the light will be able to travel, the light will come. Okay, uh, so I will show it how it will come. So this is the second thing you have to know. First one is you have to model. Okay, so just by inserting and just by giving the dimensions of the element you need, you can able to insert the model in the interface. Okay, and after that you have to select the surface properties. Okay, whether it is a glass, or whether it is a perfect observer or a receiver, a perfect observer, or uh, a black coated element or a white coated element. Okay, like that you can choose. Okay, so this is the second step. Okay, and the third step is you have to define the grid source. Okay, so that is the source of light where it will reach the element. Okay, so this is the third step. Okay, and fourth step is ray trace. Okay, so here you can able to see certain options, that is ray trace. So if you select ray trace means what will happen, certain rays, if you see from the particular the red color, I hope you have seen this red color. Okay, from this rectangular grid source only the rays are coming. Okay, not from every part. So only from the grid source the lights are coming. The lights are coming and falling on this tube. Okay, so if I select the material of the tube as a perfect mirror, means what will happen, the light will fall on this tube and it will reflect. Okay, so like that you can able to see. Okay, during analysis I will show how it is working fine. Okay, so and other options, so these are the main things you have to know about this. One is insert, and second one is you have to apply the properties, and the third one is you have to select the grid source, and the fourth one is you have to know about how you have to ray trace. Okay, so and other options, there is a new window option, and next cascading windows, multiple windows can be used. Okay, so these are the regarding to windows. Here ray trace. Okay, so as we have seen in the ray trace, trace rays, these two are similar. Okay, so you can use this race trace, or also you can use this trace race. Okay, so both are similar. Okay, so this is reverse trace. Okay, so if you select reverse trace, trace means it will back come to its original position. The trace which are the rays which are traced has been eliminated. Okay, so this is tracing, and this option is useful for reverse tracing. Okay, so and this is the irradiance map. Okay, so from this irradiance map only we can able to see the output, and we can able to analyze how much of radiance or how much of heat flux has been observed or absorbed by the tube. Okay, so depending upon the rays. Okay, so this from this we can able to see. So for seeing the results, first one you have to select the surface. Okay, so on what surface you need the results. Okay, so I have choose the outer surface. So and from that if I select the irradiance map means the values will be visible. Okay, so these are the main tools which is available in this software. Okay, so these are x-axis, y-z axis, x-z axis, y-x. Okay, so this is a orbit view. Okay, you can able to rotate on your own. Okay, so and again these are the same of what we have seen in the insert option: lens element, Fresnel lens, reflector, tube, baffle, primitive solid parts. Okay, so these are the things. So first one is lens element, and the second one is reflector, and the third one is inserting a tube. Okay, the same box will be available if you select. Okay, so baffle vanes, inserting any parts. Okay, so if you want to draw a cylinder means you can be able to draw a cylinder. Okay, so you can able to draw a cylinder from this. If you select the cylinder and right click means you can able to modify the dimensions of this cylinder. Okay, so just by modifying the values and click modify means you can able to modify the dimensions. Okay, so and you can able to draw a block. So you can able to draw a cone, and you can able to draw a sphere. Okay, so just by uh, clicking and dragging means we can able to draw the things what we need. Okay, so these are the options which are these are the tools which are available in this TracePro Expert software. So on the next we have seen what is tools, what are the different tools, and what how we have to create the geometry. Okay, so on next how we have to apply the properties. So on how we have to define the sources, and how we have to run the ray tracing, and after that we didn't see about the result analysis. Okay, so we will see it for another by taking an example. Okay, so the methodology is same. Here you have to, first one is you have to create the geometry, and the second one is you have to apply the properties, and the third one is you have to define the grid sources, and next is you can able to ray trace, and the last one is you can able to analyze the results. Okay, so there is no need of creating the geometry in TracePro software itself. Okay, if you have, or if you are familiar with other software like SolidWorks, Pro Engineer, okay, CAD. Okay, so from that also you can able to import the geometry in the format of .oml, or in the format of .sat, .stp, or .igs. Okay, so from these properties also, sorry, from these also you can able to import the geometry. Okay, so if you have selected the properties in the SolidWorks means there is no need of applying properties in the TracePro. You can skip the steps 1 and 2, and after that if you are importing, you can directly go for defining the sources, and the next is ray tracing, and the last one is analyzing results. Okay, so this is the methodology you have to include in this software. Okay, so I'm going to take an example as a solar parabolic trough collector. So for which we are going to analyze the optical and illumination analysis. Okay, so before going into this, we have to know about what are the things which are available in the what are the parameters which are available in this solar parabolic trough collector. Okay, so I hope you know or you have aware of the solar parabolic trough collector. So from that we can able to convert the cold water into hot water or steam. So if you convert the steam means you can able to run the turbine, and from that we can able to generate electricity. Okay, so these are the applications of the solar parabolic trough collector. Okay, so here the main parameter is aperture A. Okay, so I think I will enlarge the. So this is the trough collector. So this is the aperture A. Okay, the distance between A and B. This is the trough collector, which is in the parabolic trough collector. So the aperture is the distance between A and B. Okay, and the next one is rim angle. Okay, so the rim angle, it is nothing but the angle which is incident on the reflector. So you have seen, you can see, so this is the reflector, parabolic reflector. So the angle which is coming into this incident on the reflector with reference to the center line of the reflector. Okay, so this is the reflector A to B. So the center line of the reflector is this line. Okay, and the angle which is incident on the reflector is this. Okay, so this angle is called as the rim angle. Okay, so the angle between the incident ray and the reflector and to the center line of the collector, so this particular angle is called as rim angle. Okay, so and the third one is acceptance angle. So acceptance angle, that is which is represented by theta A. Okay, so here it is defined as a maximum angle which is allowing the light which makes to fall on the particular tube. Okay, so this is the uh, acceptance angle. Okay, so our next is focal distance. So at what distance we have to place the uh, tube. Okay, so we already know that a solar parabolic trough collector consists of a trough collector, so AB, and there will be a tube which will be available, or it will be placed at a certain distance from the reflector. Okay, so in the tube only what we are passing is we are passing certain water, cold water. Okay, so if you are concentrating the light on the tube means what will happen, there will be a heat transfer. So and from that the cold water can be converted into a hot water. Okay, so this is the focal distance F. Okay, so and next is depth of PTC, that is a parabolic trough collector. So the distance between the point A and this distance, this is the distance, that is depth, how depth the collector is. Okay, and next is arc length. Yes, that is the length of the parabolic trough collector. uh, Arc length. Okay, A to B, so this is the arc length. Okay, and next is concentration ratio. Concentration ratio, it is nothing but area of the collector to the area of the receiver. Okay, so here the area of the collector and area of the receiver is the tube. Okay, so by dividing we can able to find the concentration ratio. Okay, and the next is A dash. So A dash is nothing but receiver tube diameter. Okay, so these are the parameters you have to know about while designing a parabolic trough collector. So how we can able to find this parameters, that is how we can able to find the focus of a parabolic trough collector means there will be several formulas available in the journals or in the books. you can able to refer the formulas. Okay, so the for calculating the focus distance from the trough collector, you can use this formula, and there will be several online softwares available. Just by inserting the aperture area and rim angle, you can able to calculate the focus distance. Okay, so for depth of PTC, okay, so like that also you can able to calculate. Okay, so these are the things by just by substituting you can able to see this values. Okay, so next is solar parabolic trough collector. I have assumed the aperture distance as 2000 mm. Its depth is 134 mm. Its material property is mirror. Okay, so and for observer tube, the diameter is 154 mm. Its focal distance from the parabolic trough collector is 1866 mm. Its material property is a perfect observer. Okay, so these are the things I am going to take, and in the software I am going to model. So first I am going to uh, go with a new. Okay, so first I am going to insert a reflector. Okay, so you can able to see there will be a several reflectors available. So if it is compound reflector, you can able choose the compound. Okay, so I am here, the trough collector is parabolic trough collector, so I am choosing parabolic trough collector 1. I am naming it as reflector 1. Okay, the shape you can able to choose circular, parabolic, elliptical, hyperbolic. Okay, so I am choosing parabolic since it is a parabolic trough collector. Okay, so and next is I have to give the length in terms of mm. Okay, so the length I have chosen is 2000 mm. Okay, so and next I have to give the thickness of the parabolic trough collector. So it is I am choosing as a 2 mm thickness. Okay, and the next is I have to give the depth, that is 134 mm. Okay, and next is I have to give the focal distance. The focal distance I have calculated for this problem is 1866 mm. So I am giving, so 1866. Okay, you can give the axis origin 0 0 0. So as well as rotation, if you need to change means you can change. So I am giving as minus 90-degree rotation, and after that I am inserting. So you can able to see a reflector. So this is a reflector, parabolic trough collector. Okay, so on the next step is I have to choose the surface. Okay, so I have chosen the surface as material property as perfect mirror or mirror. So mirror which is capable of reflecting the light. Okay, so I have to select the surface, and I have to right click it and go to the properties, and from the surface there will be, I can choose the property as reflective mirror. Okay, and after that you can apply. Okay, if you apply, if you give apply means what will happen, the particular surface will act as a mirror. Okay, so here due to demo version it is not available, so no problem, I will show it. Okay, so this is the first step for a parabolic trough collector. Okay, so on the next step is I have to insert a tube. Okay, so I have already told it consists of two things. One is a parabolic reflector, I have already drawn, and the second one is a tube. Okay, so here I have to go with the thickness of 1 mm. Its length is the same as a reflector length, that is 2000 mm. Okay, so the shape of the tube you can change, cylinder, cone, rectangle, tapered rectangle. Okay, so I am going with cylindrical tube. Okay, so its major axis, its radius is around 74 mm, that I have already calculated. Okay, so here you have to choose at what position the tube have to be. Okay, I have already told the tube has been placed at a distance of focal distance from the parabolic trough collector. Okay, so the parabolic trough collector, it is at a distance of its focal length is 1866. Okay, so its height should be 1866 from the reflector. Okay, so I have chosen that is 1866, and I am also giving the value as 1000 for the in x-axis. Okay, and after that I can able to see a, by inserting I can able to see a parabolic trough collector. Okay, so this is the a trough collector, and there will be a tube. Okay, I hope you can able to see now. So this is the view. Okay, so this distance is the aperture, and this is the depth of PTC, and this is the focal distance from the PTC. The focal distance should be at a certain distance. Okay, so at that focal distance only the light can able to uh, observe, or the light can able to fall perfectly on the tube. Okay, so that distance is called the focal distance. Okay, so by using certain formulas we can able to see this. And next is I have to choose the surface of the tube. Okay, so that is property of the tube. So I have to go for surface. Okay, so the surface of the tube should be a perfect observer. Okay, so going for surface, you can go name, in that you can able to see a perfect observer. Okay, so if you have the option apply option, means you can able to see this uh, and the particular tube will be a perfect observer. Okay, so this is the first two steps I have completed, and the next is I have to select the grid source. Okay, so you have to go with this second column source, and from that select the grid source. So right click on this grid source, define grid source. Okay, you can able to see a box like this. Okay, here you have to give the radiation values. Okay, if it is a rectangular, so you have to give uh, the x-axis as well as length and breadth. Okay, how the grid pattern should be, yet circular or rectangular, it is depending upon your wish you can give. So the unit is radiometric, and the irradiance is unit is the watt per meter square. So I am giving the irradiance value as 950 watt per meter square. Okay, and after that I am inserting the grid source. So if you have inserted the grid source, means the grid source is available at the bottom. Okay, so and then next the last stage is trace the rays. Okay, so if you have traced the rays, means what will happen? Yep, certain rays will be able to reflect on this reflector. Okay, so I didn't choose the material properties as a uh, perfect mirror, perfect observer, because it was a demo uh, version. So I'm opening the same file. So the same file, you can able to see a parabolic trough collector with a observer. Okay, so here if I choose the ray trace option, means what will happen? The rays from the sun has been reflected with the help of a reflector, and it is observed perfectly on the, and it is fall perfectly on the observer. Okay, so this is method is called as the ray tracing method. Okay, so and there is another thing, if you want to trace more rays, means you can go with this second option, that is source. So in this source you can right click, define grid source. Okay, you select a rectangular, 950 watt per meter squared or watt per meter square. Here you can see an option that is called rays slash wave. Okay, here you can increase the number of rays. Okay, you can increase up to 1000, or you can increase up to 2000 rays. Okay, so if more rays has been, if you are given, means what will happen, the accuracy of the results you are getting will be very accurate. Okay, it is very good, and also the processing time will be increases. Okay, so if you go for higher race. Okay, so and there is another one, that is intercept factor, you can able to calculate with this software. So that is a fraction of rays which is incident on the aperture, that is a parabolic trough collector, and that are received by the to the ratio of received by the receiver. So that factor is called as an intercept factor. Okay, so that is, it is nothing but the fraction of rays which is incident on this reflector uh, to the fraction of rays which are intercepted by the observer. Okay, so that rays is called as an intercept factor. Okay, so you can able to find the intercept factor. Okay, so next is analyzing the result last. For analyzing the result, you have to choose the surface. So I am choosing the surface, tube surface. So for this surface I am going into analyze. So for analyzing, you have to go for the irradiance map. So if you click on this, there will be a output will be available in terms of heat flux. Okay, so this is the outer uh, this is the outer tube, and this is the inner tube. So if you see the total flux which is received by this observer is 2314.6 14.6 watts. Okay, so here by this color variation you can able to take the values. Okay, if you right click on this results, means you can able to see irradiance options. Okay, in this options you can change the things, irradiance in terms of xy, in terms of u dash v dash. Okay, you can able to rotate right and left, or in terms of quadrant. Okay, so if you want any further display options, counter plot, okay, like that you can able to uh, select. Okay, also you can able to uh, change the color of this uh, output results depending upon your wish. So I'm giving as a set defaults. Okay, so this is how you have to model, and you have to take the output from the uh, TracePro software. Okay, so here from this I can able to say that around 2308.4 watts has been observed on the tube. Okay, so I have already uh, draw a tube. So from the rays, that is 950 watt per meter squared rays or irradiance value, So I have received the tube total flux value as 2600 watt. Okay, so this is how you have to uh, analyze the output. Okay, so there are several softwares available other than this TracePro. So like Soltrace software, SOLTRACE, Soltrace. So it is a free version. Okay, so there is no need of paying cost to getting the software. So if you have googled it as a Soltrace, you can able to download and you can able to do the same on the Soltrace software. Okay, so and there is another software which is called as Ray Trace 3D, which is also available. From that also we can able to get the heat flux or flux, total flux which is observed on the observer. Okay, so spray, star, okay, like that softwares are available. Okay, so I will send the PDF documents or tutorial of this TracePro software, which is available with me in the WhatsApp, which is available with me. So I will share the tutorials how we have to draw and how we have to do. Okay, so and also I will show some of the diagrams which have been already available. So here that you can see a lens part. Okay, so camera lens. So how much of light is coming and how much of light is able to incident on how much of heat flux has been uh, fall on the particular object. Okay, so like that we can able to analyze with the help of this software. Okay, so these are the some of the models which is available with me. So uh, if you want to import from SolidWorks also, you can able to import. Okay, so I think I have ended. So if you have any questions and you can post your questions or you can unmute and you can play. So I am used this software only for a parabolic trough collector, that is a solar applications. Okay, uh, so that's it. If you have any doubt, you can ask. Since I I don't have much time, that is 1 hour, so I cannot. I'm going. I was very fast during the session.
Participants, if you have any doubt, kindly post the questions in your chat box.
Yeah, main key features. Yeah, you can able to analyze the optical analysis. For example, I have told the solar radiation value which is coming from the sun. That is solar constant value is 1057 watt per meter square. Okay, so from the 1057 watt per meter square, how much of light has been observed or how much of light has been utilized by the tube, so that can be analyzed with the help of this software. Okay, so you can use, yes, I will send the photocopy and all those. So it is very easy software, user friendly, Okay, so it is available in the net. There is a lot of tutorials, videos available in the net. Yes, I don't have a demo. I have just download this demo version now. That is last week. So I was uh, in the project during my ME. So I did my project in solar parabolic trough collector, and I did my analysis, optical analysis with the help of this software. Okay, so with the one of my researcher friend has given this software. They have given the cracked version of this software. Okay, uh, so if you see. mm, 1 second, I will show it. So this is the OML format I have used for my ME project. Okay, so here you can see a surface 0. So if you right click and if you see the properties, the surface is a perfect observer. Okay, so it is already predefined. So that is why the results are showing without even in the demo session now. What is the main advantage? Yes, you can able to do the optical analysis. Okay, how much of light you are getting from the source, and how much of light you are utilizing uh, for a particular object. So you can able to find the intercept factor. I have already told. You can able to find the fraction of light incident on an aperture to the fraction of light which is received by the interceptor or observer. Okay, so heat flux values you can able to find from with the help of this software. Okay, so intercept factor, so those are the things that you can able to do. So since I was analyzing only the solar related, so I don't find other advantages. Okay, so if you are from physics department, or if you are from other departments which is or you are working in the research area in terms of light or in terms of others related to optical and illumination, this software is very useful for you. So I already did some work in this. Uh, can we give the heat transfer to water if we give? No, we don't have such options like heat transfer analysis in this software. Only we can able to find how much of light has been observed on this observer. So we cannot able to find the heat transfer analysis. For that, I will suggest computational fluid dynamics. From that, we can able to find the heat transfer analysis. So any other questions? Okay, thank you, participants. I don't have much enough time, so that I was very fast. So thank you, and I thank all the faculty coordinators, vice principal, principal, and the management for giving the opportunity for this wonderful webinar. So you can, so since this is the, what are the disadvantages? Yeah, disadvantages, this software is costly, and you can able to only analyze the optical and illumination things. Okay, we cannot able to find about the heat transfer analysis. Okay, so this software is mainly for uh, analyzing the opticals and illumination. Okay, other than that, we can able to analyze. So that is the disadvantages.
Good evening to our principal. I deem it a great honor and privilege to propose the vote of thanks on this memorable occasion. Let me first start by giving glory to the Almighty God for making today's occasion a resounding success. First and foremost, I thank our special chief guest, Mr. K. Vigneshwaran, Assistant Professor, Department of Mechanical Engineering, Ramco Institute of Technology, who, despite his busy schedule, has found time to grace this occasion. I thank him for his kindness, his interest, his hospitality, and continued support. Thank you, sir. I thank our principal and vice principal for their unstained support for this function. I heartfelt thanks to the various head of the department and the faculty for their valuable contribution, guidance, and encouragement in all our effort. I special gratitude to the who have worked hard and ensured that this occasion becomes a memorable success. Thank you, event coordinators. I thank all the distinguished invitees present here and accepting our invitation. Last but not the least, I thank you, my friends, for your cooperation in making this function a resounding success. Finally, I leave you an inspiring quote by Martin Luther King: an individual has not started living until he rises above his convictions of his individualistic concern to the broader concern of all humanity. Once again, I thank you all for your attention. Thank you, sir.
Satish Surya Vanshi. Yes, you can use this software which is called Soul Trace. So it is free software. Okay, so for that you go to the Google. So if you go to Google and type Soul Trace software free download, means you can able to see the link from the website, that is NREL. Okay, so if you click on this link, it will ask your basic details: first name, last name, your mail address, your organization, where you are working or where you are studying. Okay, so what is your planned use of this Soul Trace software. Okay, so and from that, if you click download, means you can able to download the software. You can see the guidelines for inserting the software. Okay, so which is very free. So it will be very similar to the software TracePro and Soul Trace. So but its techniques are little bit different. Okay, so this software is as for me, this software is user friendly, TracePro. So Soul Trace also very useful. So if you keep on practicing it,